Share screen. This is experimenting. Usually my computer gets slower, but we can try. All right, so you guys, breaking vectors into components. Are you done? Okay, so Hadi, was it Hadi talking? No, Kifah. Kifah, how would you find Vx and Vy? To be honest, personally, I'm too anxious. I would do some mistakes. I would love to draw first to make sure I understand how it looks like. So this is my x-axis. Quickly, it's like a sketch. This is my y-axis. Okay, I'm gonna draw the vector, let me see, it's making an angle of 30 degrees with the positive x-axis. So this is how the vector looks like. This is the x components, come on, I need, okay, so this is my x component and this is my y component. Okay, and this is the angle we're talking about. How do you proceed, Kifah? Okay, so 3.0 times cosine 30. Okay, is it positive? Okay, it's pointing to the right, so it's positive. I know Sherbel is following and Sherbel is doing right. Yeah, continue. Okay, so 2.6 meter per second negative 1. Continue for the next one. Is it positive or negative? Yeah. Yeah. So we don't think it's exactly the same thing but opposite. Like simply write the same equation, but be careful with the minus. It could be minus or plus, and the final answer is it 1.5? Yes, meter per second squared. So we just broken the vector into two components, okay? Usually we do this to be able to add two vectors, but here you don't have two vectors to add. Your job is only to break it down into two components. Any questions? Yeah? So far, yeah, so far so good. All right, I'm gonna ask Shadi. Shadi, let's try to do the math. You are given Vx, you are given Vy. If you want, we can draw them. So this is your x-axis. Okay, see the drawing is a little bit slow. It could be from the recording. I know that Vx is negative, so this is Vx. Vy is positive, so in this case, which means my vector is pointing in this direction. Anyway, they want you to, and this could be a good angle to calculate. Okay, how would you find V? Um, no, you can do whatever you want. Maybe I can help you out by showing you that this is 6.2, okay, 6.2, and this is 3.2, okay. So let me know if my internet is glitching. Yes. So when you do the opposite thing, you don't use trigonometry anymore. So Pythagorean theorem means you do the square root of, right, of 6.2 squared and plus 3.2 squared. You're supposed to, I just ignore, okay, 6.9 meter per second to the negative 1. Okay, so I just ignored the negative sign for the 6.2 because I'm squaring it anyway. And how do you find the angle? Shall I do tan minus 1? Okay, in other words, it's shift tan of the opposite over adjacent, which is 3.2 divided by 6.2. Yes, so any answer? $29. Okay. You can say above the negative x-axis. Okay. negative x-axis. Usually this is the easiest way to say it. So you just say it's above the positive x, below the positive x, above the negative x, below the negative x. All right, you guys, I think the lesson is over. If you are being able to do this, it means the lesson is over. I fetched for us some problems to try. Let me put them under classwork. So let me zoom out a bit. Maybe you need to take a screenshot to finish this. Take a screenshot if you need to finish it. And I assume now everybody is on the copybook helping out with the classwork. Let's try to do nothing today but sit together and finish the classwork. Maybe no homework will be offered to you, okay? Let me know if Ivan and Wissam will be able to join because I'm not checking on the attendance, okay? And let's see if us being able, okay, how can I move this down? I won't be able to, okay, I can. Okay, let me say this is classwork. Okay, what does it say? Can I split these two? Yes, I can. Okay. Sherbel, can you help me out? Okay, let me see. The problems are in order. Did I plug in two problems only? I remember we had three problems because I remember there's one that was easier. Let me check. I have them here. So insert picture. Let me check. This one looks easier. Okay, let's start with the easy one. Okay. It's here. Where do we find these problems or the vectors? Should I say it again? Okay, I will let you know. So let's try to do this together. Shadi, Sharbel actually, this is an easier problem to start with. You have two vectors, A and B. You have the angles and you have the magnitudes. Maybe I can simply draw. Wissam is trying to join. Ya Allah, he's not being able to. I want a highlighter. Okay, that is. Yes, I can hear you. I'm sorry for your internet connection, but don't worry, we're recording the session. Try to follow as much as possible. All right. Yeah. So for the vector A, yeah, I need to find, so for the vector A, I need to find AX, so small AX question mark, and that's the job of Sherbel, and small AY question mark. Can you try to do that? Maybe I can help you out by showing you that this is AX and this is AY. So maybe start by stating that AX is equal to negative or positive. Think about it. AY is, yes. What about AY? Also negative. So this one I'm gonna write A and this I'm gonna write A. Then I'm gonna say multiplied by. Do you see AX being adjacent or opposite to the angle 45? So it's cosine. So let it be cosine 45 degrees. Automatically, the other one is going to be sine 45 degrees. Okay, done. Now give me your final answer. Meanwhile, I can ask, let me see, Hadi to do vector B. And Tony, you're next. So I'm going to show Hadi. I'm going to show Hadi that this is Bx and this is By. I'm doing the drawing for you. And at some point, I would be worried that you don't know how to do it. So this will come later, maybe in a homework or something. Yes, Sherbet, do you have an answer before I move on to Hadi? I need a decimal, please. We're doing science, not math. Let's try to round to two significant figures, يعني two digits. Okay, I'm gonna say 8.5. Just trying to round. All right, what is the unit, Sherbel? Newtons? Meter per second? It's units. Okay, so the unit is called units. And this, I think the same answer, right? Yeah, every time you have 45 degrees, this happens. All right, back to you, Hadi. Quickly tell me Bx and By. Thank you, Sherbel. Positive, negative, which is positive, which is negative? Hadi. Thank you so much. Yeah, continue. Yes, 30 degrees. Awesome. Yes. Replace. Yeah. 20.78. I'm gonna round it to 21. Okay. And the unit is units. 12 units. Okay, done. So you see, so far things are getting normal, back to normal. I know you guys enjoy algebraic methods more than graphical methods. It's the same with me, but graphical methods is good for beginners to see how things work. Okay, now I need Tony with me. Tony, we need to find the X and Y components, but the weird thing in this drawing is that the x-axis is in this direction. Let me use red because it's a lot of blue involved. So this is your x-axis. Usually it's a very important way to see it because it's an inclined plane and we take the x-axis along the plane to make my life easy. So you're gonna wonder, why is Miss Jessie tilting the x-axis to make her life difficult? No, actually I'm trying to make my life easy. You will discover later why is that making your life easier. Now this would be your x component and this would be your y component. So x component is pointing in this direction and y component is pointing in this direction. Now concerning the angle that is here, is it equal to theta or not? I can see that it's equal to the complementary of theta, isn't it? Let me try to show you. So you see this triangle and you have a 90 degrees. Is Tony with me? Okay, so Tony, do you see that this angle is not theta, it's the complementary to theta. So if theta is 30, this one is 60. Do you agree? All right, so it's the complementary, so they add up to 90. Anyway, you don't have values in this question, so you have to only write the equation, okay? And I can help you out. So the vector is called W. Our job is to find Wx and to find Wy, okay? Let's try with plus and minus. Do you agree that Wx is positive because it's pointing in the x-axis? I took the x-axis in this direction. If you don't agree, I can simply remove this, okay, and point the x-axis like you want, Tony, so you lead. Which means in your case, the case of your x-axis, it's gonna be negative. What about Wy? It's also negative. Okay, so this, I'm gonna write W. By the way, W represents the weight, times multiplied, times multiplied. Okay. The x-axis, let's call this a weird, a tiny angle. I'm gonna call it angle. Do you use cosine or sine for the x component? Okay, I'm gonna say cosine angle, all right, because it's not theta, and this is sine angle. All right. I love this. Thank you so much. I'm gonna write the whole thing again. I'm doing it slowly just to see if you guys can see it. I'm gonna write 90 minus theta. All right. And same thing with this one. Anyone would see any further simplification? What is cosine 90 minus theta? Do you know? Yes. Kifa has something to say. Yeah. Yes. Of course. Of course, Kifa. I was waiting for this tip, this magical tip. So you can use any rule you want, but some students do not know all the rules, and this is the beauty of physics. You don't have to use any of the rules. So let me say it again. Kifa is trying to say that, do you guys know that cosine 90 minus theta is actually equal to sine theta? So I'm asking now everyone, do you guys know this? If you don't, you can simply skip it as such. If you do, you can make your life so much simpler by stating all of the above, but then you replace, okay? So I'm showing you that this will turn into sine theta, okay? Who knows this equation other than Kifah? Okay, all right. So for the students who do not know this equation, you can simply uh, keep it somewhere. I will try to use it, but Shadi, say it again, ما سمعت. Okay, so, all right. So if you want, I can tell you sine of 30 degrees is actually equal to cosine of 60 degrees. This is what we mean. Okay, so this is what we mean. We don't really use it in physics unless we are not given the values. Okay, Tony, thank you so much. Kifah too. Everyone else? Yes, yes, yes. Okay, so maybe you did not see it. Let me see if we can see it together. Okay, do you see that the vector W is actually vertical? This is confusing. We don't care about finding the vertical and the horizontal component. We care about finding a component parallel to the x-axis, Shadi, and a component perpendicular to the x-axis. So now my job is to find a component parallel, like a shadow on the x-axis and a shadow on the y-axis. Okay? This is a very confusing example. Many students do not understand this example until they do it many times. This example is very important in physics because you need, it's an inclined plane and it's a famous example. So maybe, Shadi, with time, by the end of grade 11, or sometimes now my grade 12 students still struggle with this, they end up knowing it like by habit. Okay? All right, so now the vector is vertical, but my axes are tilted. If you want, I can draw it. Usually I do this to my students. I say, imagine the x-axis is straight. Imagine the y-axis is straight. And now the vector I want is actually pointing, where is my blue pen? Pointing in this direction. This is y, okay? So just imagine, instead of y being vertical, imagine the axis being straight, but the y, the w to be tilted. And this is the angle we're talking about, that is 90 minus theta. Okay, this is the only way to be able to push my students to understand this, because many of my students wouldn't understand why I'm breaking down a vertical vector anyway. Okay, shall we move to a new question? Okay, let me see what the question is about. Find the sum of the vectors. So Wissam, can you proceed? Okay, so what do they want? Okay, you guys, I want you to see that these are two digits, 8.0. These are 12 two digits, and the angles are two digits. Let's try to give answers two digits as well, okay? Just to make it a good habit. Yes, so what do you suggest, Wissam? What do you suggest you do? Yeah, how do you find F1? Okay, I'm gonna do F1x, F1y. Then I'm gonna do F2x, F2y. Then what? Then add them together. So F1x plus F2x, is that what you're saying? And add this together as F1y plus F2y. And eventually find the resultant that I'm gonna call R and maybe the angle of it. Okay, so what I just did here, I've broken F1 into components, that broken F2 into components, then I added the X components, adding the Y components, then building a new vector out of this result. Okay? So what I'm doing here, breaking vectors into components, then building a new vector that is the resultant. Yeah? Shall we try? Wissam, you do the first vector. Yeah. No, no, you can use 42, no problem. But make sure you add a minus. هلا. Yeah. Yeah, yeah, yeah. 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 Okay. Multiplied by cosine 42, 28, right? Okay. Listen, that's F2. Okay, wait a second. All right. So basically, this is F1. So the angle has to be 42. And be careful, this is the X and this is the Y. So I'm talking to myself when I said be careful, Jesse. So this is minus and this is 42. So I was looking at F2. My bad. Okay. If you want, if you, okay, let me Okay, let me explain what Wissam is saying because we never discussed it as such. Wissam is saying always use cosine for the x, always use sine for the y, but don't take any angle. Always measure the angle from the positive x-axis. In our case, we never thought as such, so it's up to you to follow any method you want. In Wissam's case, he doesn't draw the x and the y component. We need to draw the x and the y component to see if it's positive or negative. Okay, so this one is gonna be positive 8.0 times the sine 42. So Wissam, your method is right, but I don't want to confuse your friends, so that's why. Do you have a final answer for this one? Okay, I'm gonna round it to 6.0 to make it two digits, and the unit is units. What about the next one? 5.35 or 5.4 units. Okay, I'm using two digits. Thank you so much, Kirill. Can you continue for this one? So I'm gonna say both are positive. We already drew them. F2, yeah. Yeah, 10.59. Leo, you continue the work, okay? يلا كيرل. 12.23 units. 6.3. Okay, give me a moment so I round to 2 digits. This would be rounded to 11 and this will be rounded to 12, to 13. Okay, this rounding issue will bother you for some time. It's only for my DP students to have this habit. For the grade 10 students, do whatever you want, but it's good to get used to the rounding thing because you need to do this later on anyway. So I'm actually rounding to 2 digits because the given is 2 digits and 2 digits. That's why they said 8.0 and not 8. To tell me, please round your final answer to 2 digits. All right, so back to Leo, please add these two. It is 2 digits. I'm not rounding decimals, I'm rounding just digits. Yeah, good question, Shad. Yes, Leo? Yes, so I'm gonna write 5.0 to keep it 2 digits. And this one, okay, I'm rounding it to 18 units. Okay, how would you find now the magnitude? If you are given x to be 5 units and y to be 18 units, how would you find your vector r? Yeah. What? Okay, I'm so sorry. You were glitching at some point. So I'm sorry I couldn't hear you. So this is 5.6. Let me fix this one to 5.6 and then right. And this one will be what? 11? Am I right? Yeah. Please always keep track. Like for example, F1 and F2x. Sometimes I may pick random values and do mistakes. Keep track for our calculations. Leo, or how do you find it? All right, so again, Leo, you are given X, you are given Y, and you need to find R. So in other words, you know that this one is 5 units and this one is 11, okay? Exactly, yes. So I'm gonna say square root of, you do the work for me, 5 squared plus 11 squared, and the answer is, yes, Kirill, you were saying something? 12.1 units, right? Okay, round it to 12 units to make it 2 digits. And now for the angle, I'm gonna do tan to the -1 of opposite. So we're talking about this angle that is in here. Okay, so this is the opposite to it. So yes, help me out. Opposite is 11 over 5, right? Final answer. Is Leo talking? No? 65.5, I'm gonna round it to 66 degrees. Okay, if you want, you can say above the positive x-axis because I can see it, because I drew it above the positive x-axis. I'm very impressed with a arctan. Tan to the -1 is the shift tan or arctan or invert tan. It's what I'm just mimicking what you see on the calculator. I'm gonna save this, stop sharing and recording from